Hello students and welcome back to my channel. Today I have come with all the questions which were asked on 31st of January 2023 JEE mains. So all these videos are in continuation with each other. Okay, I have divided all the chapters and all the things topic wise and chapter wise. All the questions you can find topic wise and chapter wise. So without wasting time, let us move to the first question. As you can see, the first question is a match the column question. You can see there are four physical quantities on the left hand side, and the corresponding dimensional formulas have been provided in the right hand side, list two. So we have to match them one by one. So starting from the first, we have angular momentum. Now as we know, angular momentum, simplest formula, you can think of the simplest formula for angular momentum. If a particle of mass m goes along a circle of radius r with a speed v, then its angular momentum is the product of mvr. So for m we have m itself, velocity is L by t and r is L. So as you can see, it is ml square t power minus 1. So A should be mapped with third. So you can see A is mapped with third. So hopefully we got the answer, because you can see for the rest four of the options, A is matched with different things. So we got the answer, but just for your convenience, I am continuing with the rest of the physical quantities. Coming to the second one, that is B, torque. The formula for torque is force into lever arm. So dimension, it will be force into some length distance. So force is ml square, ml t power minus 2 and 1 square here. So ml square t power minus 2. Okay. So torque should be mapped with 1. So as you can see, B is mapped with 1. Then coming to stress. Stress is nothing but force, restoring force per unit area. So it is just like pressure. Okay. So stress is restoring force per unit area. For force we have mlt power minus 2. For area we have L square. So finally we have ml power minus 1 t power minus 2. So stress should be mapped with 4, C with 4. And pressure gradient, finally we have, now pressure gradient is the fall in pressure per unit length as we move in the direction of the flow of liquid through the pipe. As we all know, when liquid flows through a pipe, there is a pressure difference across different sections. So normally the liquid will flow in the direction in which pressure decreases. In other words, liquid always flows from higher pressure to lower pressure. So the fall in pressure per unit length will be the pressure gradient. So dimensionally, change in pressure is equivalent to pressure, and change in length is equivalent to length itself, whatever it is. So pressure means force per unit area and length. Force is mlt power minus 2, area is L square and another L. One L gets cancelled, you can see. So finally we are left with ml power minus 2 t power minus 2. So pressure gradient should be mapped with 2. So yes, D option is the correct option. Moving on to the next question. A body is moving with constant speed in a circle of radius 10 meters. The body completes one revolution in 4 seconds. At the end of third second, the displacement of the body in meters from its starting point. Let us draw a simple diagram to understand the situation. Okay. So the situation is like this. As you can see, it is moving along a circular path. Let us say that the body starts from point A. O is the center, R is the radius. Now as you can see, it is given that the period of revolution is 4 seconds. So each quarter, it takes a time 1 second to describe each quarter, because 4 seconds means 90 degree, 90 degree, 90 degree, 90 degree. Now at the end of third second, it would have moved 3 quarters. So that means it would have come to position B in this way, isn't it? Because at the end of 1 second it is here, at the end of 2 seconds it's here, at the end of 3 seconds it's here. So the displacement will be the straight line joining the initial and the final positions. So this one is the, you can see we require just the magnitude of displacement. So the required displacement is nothing but the length AB, modulus of displacement. So this, as if you apply Pythagoras theorem, you can very easily see, or you can apply some trigonometric ratio, sine or cos. It is r root 2. Since radius is given as 10 meters, so the final answer is 10 root 2 meters. Moving on to the next question. The initial speed of a projectile fired from ground is u. At the highest point during its motion, the speed of projectile is this, the time of flight of the projectile is. Now, we require the time of flight for the projectile. Okay. So, in simplest terms, the if alpha is the angle of projection and u is the speed of projection, then the required total time of flight will be 2 u sine alpha by g. So even though u is given, we require alpha. So in order to know alpha, we have been furnished with the information that the speed of the projectile is this at the highest point. As we all know, at the highest point, only the horizontal component remains. So if the horizontal component is root 3u by 2, which is also equal to u cos alpha, then you can see that cos alpha is root 3 by 2. In other words, alpha is 30 degrees because cos 30 is root 3 by 2. So here we have to put the value of alpha, which is 30 degrees. So sin 30 is half, so 2 gets cancelled. We are left with u by g. This is how you are supposed to calculate. Moving on to the next question. Two bodies are projected from ground with the same speeds 40 meters per second at two different angles with respect to horizontal. The bodies were found to have same range if one of the bodies projected at an angle 60 degree with horizontal, then the sum of maximum height. As we all know that in order to have the same range, the two angles of projection must be complementary to each other. In other words, if one of the angle is 60 degree, the other should be 90 minus 60, that is 30 degree. What are complementary angles? Whose sum is equal to a right angle, that is 90 degree. So when projected with the same speeds at two different angles of projection which are complementary to each other, the horizontal range remains same, that we all know. Now we have to find the sum of the maximum height. Let us say the maximum heights are h1 and h2 in the two cases respectively. Then we have to find h1 plus h2. Okay. Now as we all know that the maximum height is given by u square sine square alpha by 2g for the first, and for the second it will be sine square of 90 degree minus alpha by 2g. So finally we can write like this, because this will be sine square alpha and this will be cos square alpha. Taking u square by 2g common, we are left with sine square alpha plus cos square alpha, which is equal to 1. Here alpha will be 60 degree. Any one of the angles you can take it as alpha. So I have taken, let us say, 60 degree. So not a problem. Just substitute the values, students. So u speed is given as 40. So 40 into 40 upon 2 into g. G is given as 10. So 1 0 gets cancelled. 2 2s are. So 2 into 40 is 80 meters. Okay. So this is the answer. So correct answer will be 80 meters. Moving on to the next question. The speed of a swimmer is 4 kilometers per hour in still water. If the swimmer makes his strokes normal to the flow of river of width 1 kilometer, he reaches a point 750 meters down the stream on the opposite bank. The speed of the river water is. We can take x-axis as the downstream and y-axis as the direction perpendicular to the water flow. So what is flowing along in this direction, along x-axis? That is known as the downstream direction. Downstream direction is the direction in which water flows, right? So let us say that the swimmer starts from point O and he finally reaches here. Okay. As is given, he is attempting to move perpendicular to the flow of the river, that is along the y-axis. That is his own velocity, which we can take it as v, is along perpendicular to the river, but the river flow is in the east, is in the downflow direction. So now as a resultant, the resultant velocity will be in this direction. So VR. So actually is moving this way. So it is given that the river is 1 kilometer wide. By the time he finishes his journey, he is already 750 meters downstream. He is already drifted 750 meters downstream. So now you can see that his own velocity is given as 4 kilometers per hour. I am not writing the unit, it is assumed as kilometers. Okay. So I can say that in time t, the displacement along y-axis is 1 kilometer with a speed of 4 kilometer per hour. Now in the same time t, the displacement is 750 upon 1000 kilometers with a speed u along x-axis. Okay. In other words, we are considering the motion separately along y-axis and x-axis. So considering the motion along y-axis, it is easy to see that the time is given by displacement upon velocity. Okay. Whereas along x-axis, when you consider the movement along x-axis, the displacement is 750 upon 1000 meters, which is 750 by 1000 kilometers upon u is also t. So if you equate these two, then you will be getting uh, 1 by 4 is equal to 3 by 4 u, so which implies u is equal to 3 kilometers per hour, of course. This I have cancelled with 253s and 254s. Moving on to the next question. All questions are over, students. Thank you so much for watching my channel. Kindly subscribe to my channel and hit the like button. Thank you.